Okay, this is handout 3. What is a sample space? So again, follow along with me, hit pause if you have a question, raise your hand, and slow down the video if you need to catch up. So sample space describes all of the possible outcomes of an event. So the New England Patriots and the Dallas Cowboys are playing. What are the possible outcomes of the game? So what are the possible outcomes? The Patriots can do what? They could win or they could lose. And the Cowboys could win or lose, right? A number cubed is rolled. What are all the possible outcomes? So if you roll the dice, what are all the things that could pop up? What do you think? A 1, a 2 could pop up, a 3 could pop up, a 4, a 5, or a 6. Those are all the things you could roll if you roll a dice. So that's kind of what a sample space is, everything that could possibly happen. Sample space can be displayed with lists, tables, or tree diagrams to determine the probability of a compound event. Compound means more than one. Okay, so we're going to figure out kind of these compound events. It says for breakfast, Jamie can choose from cereal, eggs, or a muffin. She also can drink coffee, orange juice, or milk. What are all the possible outcomes? How many total outcomes are possible? Okay, so she can, for breakfast, she has 3 choices, right, of what she can eat. She can get eggs or a muffin, and for drink, she can get coffee, orange juice, or milk. So we're going to do a list or a table. So basically, I have to match everything up. If she picks cereal, she can get coffee. If she picks cereal, she can get orange juice. If she picks cereal, she could get milk. So that's her cereal choice. Those are all the things she can get if she gets cereal. Cereal coffee, cereal OJ, cereal milk. So now let's do eggs. If she picks eggs, she can get eggs and coffee. She can get eggs and OJ, good. Or she can get eggs and what? Milk. Okay, so what do we have left to do? She did cereal, we did eggs, so now we have to do muffin. So if she picks a muffin to drink, she could get coffee, good. If she picks a muffin, she could get OJ. And if she picks a muffin, she could get milk. So how many different possible combinations do we have? So we have to count 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 9 total outcomes. And here's kind of a trick. She had 3 meals, 3 foods to choose from, and 3 drinks. Well, if you multiply those together, you get 9. All right? So let's look at the next one. It says, a fair coin is tossed 3 times. What are all the possible outcomes? How many total outcomes are possible? So we want to do a tree diagram. And we have 3 trials. So I'm going to do trial 1, trial 2, trial 3. On trial 1, when she flips her coin, she can flip a head or a tail, right? In trial 2, she can also get a head or tail. So if her first coin is a head, her second coin could be a head also, or it could be a tail. If her first coin is a tail, her second coin could be a head, or it could be a tail. So she could get heads, 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 tails, tails, heads, or tails, tails. But we're doing it 3 times. So if she gets heads, heads, on her third one, she could get heads again, or she could get tails. She could get heads, tail, heads, heads, tail, tails. She could get tails, head, head, tails, head, tails. Or she could get tails, tails, heads, tails, tails, tails. So here's all the different combinations she could get if she flipped her coin 3 times. So if you notice, that's 1, 2, 3, 4, 5, 6, 7, 8. There are 8 total outcomes. And the way we could figure that out is on trial 1, she could get heads or tails, so that's 2. Trial 2, she could get heads or tails, so that's 2. And trial 3, she could get heads or tails, and that's 2. 2 times 2 is 4. 4 times 2 is 8. So that's a tree diagram. You'll see a lot of those on the map test. Okay, so number 3 says we want to create a list of all the possible outcomes. Amanda will roll a number cube, underline that, and flip a coin. If Amanda rolls a number cube once and flips the coin once, what are the possible outcomes in which the number cube lands on an odd number? Okay, so when she flips her coin, or I'm sorry, when she rolls her number cube, she can get a 1. And when she flips her coin, it could be heads, right? If she rolls a 1, she could also flip her coin and get a tail. So she's rolling a number cube and flipping a coin at the same time. If it lands on a 1, it could land on a heads. If it lands on a 1, it could land on a tails. But it could also land on a 2. If it lands on a 2, the coin could go heads, or it could go tails. If she rolls a 3, she could get a 3 and a head, a 3 and a tail. For 5, she could get a 5 and a head, a 5 and a tail. Oops, I forgot 4, didn't I? So 4 could be 4 in heads, 4 in tails. And now we need 6. 6 could be 6 heads or 6 tails. Now the question says, how many possible outcomes will the number cube land on an odd number? So we only want to look at the ones that are odd. So that's this set, this one, and this one. So how many is that total? 1, 2, 3, 4, 5, 6. There are 6 total outcomes. Okay, hit pause and try to do number 4 on your own. Create a list, hit play, and then check your answers. Okay, so hit pause, do that one on your own, and hit play when you're ready. Okay, so hopefully you should have a list that looks something like this. If she spins a 1, she could spin a yellow, a 1 in a red, a 1 in a blue, a 1 in an orange. For 2, she could spin a 2 in a yellow, a 2 in a red, a 2 in a blue, and a 2 in an orange. She's spinning this one and this one at the same time. So that's what you should have gotten, which should have been 8 total outcomes. So if you are unable to get this part, make sure you're asking for help. Don't just be copying words down. Make sure you understand how we're getting that. Okay? For 5, I want you to do the same thing. Hit pause, read the problem, and create a tree diagram. A tree diagram. That's what we did on the previous page. It says a clothing line has shirts in red, blue, or white, and pants in gray or khaki. How many different combinations can be made? So remember, you're going to have a row of shirts, and then you're going to have pants. So hit pause and create your own tree diagram to figure out all the different outcomes. Okay, so you can do your tree diagrams a bunch of different ways. I'm going to do mine going across this way. We have shirts and pants, right? If she picks a red shirt right here, she could get gray or khaki pants. That's one combination. If she picks a blue shirt, she could get gray or khaki pants. She could also pick a white shirt and pick gray or khaki pants. So she can get a red shirt with gray pants, a red shirt with khaki pants, blue shirt with gray pants, blue shirt with khaki pants, white shirt with gray pants, white shirt with khaki pants. And this is 1, 2, 3, 4, 5, 6 total outcomes. Now you could have done it up and down, where it would have been red, gray and khaki, blue, gray and khaki, white, gray and khaki. They're both the same. Again, if you were unable to get this, raise your hand and get help. So again, hit pause for number 6 and try that one on your own. When you're ready, hit play to check your work. When buying a car, Esther can choose a 2- or 4-door car, so that's our first choice, with leather or cloth interiors, and black, silver, or white. So we're going to pick the number of doors, the interior, and the color combinations, okay? So if she picks a 2-door, she can get leather or cloth. If she gets a 2-door with leather, she can get it in black, silver, or white. If she picks a 2-door with cloth, she can get that in black, silver, or white. So these are all the combinations she could get if she got a 2-door car. A 2-door with leather black, a 2-door leather silver, 2-door leather white, 2-door cloth black, 2-door cloth silver, 2-door cloth white. So now we're going to do what she picks a 4-door. She can get a 4-door with leather or cloth. If she gets a 4-door with leather, she can get it leather. She can get it black, silver, or white. If she picks a 4-door with cloth, she can get it in black, silver, or white. So she has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 total outcomes. And to check to see if you're right, she had 2 door choices, 2 leather or cloth choices, and 3 color choices. 2 times 2 is 4, 4 times 3 is 12. That's how you do your work. All right, at the where it says summarize today's lesson, draw a happy face with a hat on his head. That way I know you watched the entire video. Again, if you have any questions on how we came up with these, raise your hand and get help. Don't just copy. And go ahead and start your homework.